Hey everyone, now we're starting the presentation. So we got a brief overview of data structures and algorithms. Now, in order to make this concept easier for you, I would like to compare data structure and algorithms to cricket because everybody has a good idea about cricket and everybody loves cricket. So data structures can be compared to the different types of cricket equipment or different types of cricket players. And we know how different cricket players have their own abilities and their own skills. Same way, data structures have their own abilities and their own structures. And algorithms are similar to the strategies and techniques used by these cricket players to win their goal. And the goal is basically to win the game. In a similar way, the goal of an algorithm is to find the optimal solution with efficient time complexity and space complexity. So we shall be studying about the following data structures throughout our 8 days. We'll be studying about linked lists, double linked lists, stacks, queues, trees, graphs, heaps, recursion, tree traversal, and various sorting algorithms. So let's just take a brief overview of these data structures. Linked lists are basically lists which have nodes as their elements, and nodes are a derived data type. They're not a primitive data type like integer and character. We shall be studying more about them in our next lecture. And linked lists have every element in a linked list points to the next elements using a pointer. And in a double linked list, you will be having an element that points to the next as well as the previous element of the linked list. In this way, a double linked list can traverse both ways. Then comes the concept of stacks. We know how in a stack you arrange one element on top of the other, and the element that exits the stack first is the element that was inserted last. So this is considered as the concept of last in first out data structure. If you want to reach the first element of a stack, you'll have to first get through the top element of the data stack and keep on going through it, and then you can reach the bottom of the stack. And then comes the concept of queues. In a queue, you arranged data in a sequential manner, and the element to leave the queue first will be the element that was added first, which is considered the first in, first out data concept. Now coming to the concept of hash tables. Hash tables use hash functions to generate a key, and then we assign these keys into the tables, and accordingly we retrieve the keys to retrieve the element pointing towards it. Hash functions are used in cybersecurity. And next comes the concept of trees and graphs. Trees are essentially a graph, and a graph is nothing but a collection of nodes which is connected to other nodes using edges. So every tree is a graph, but every graph is not a tree. A tree is a graph that follows a hierarchical data structure. In a tree, you have the parent node, and then it is followed along by its child nodes. A tree can have multiple children, and the trees that we'll be studying about will be binary trees, which have just two children maximum, either 0, 1, or 2 children. Then comes the concepts of heap. A heap is nothing but a binary tree which follows a specific order when it comes to the arrangement of the elements. There are two different kinds of heaps, that is a max heap and a min heap. In a max heap, the parent node has the highest value, and as you traverse through the tree, the value of the nodes starts decreasing. And in a minimum heap, it's the opposite way around. The value of the parent node is the least value, and as you traverse through the tree, the value of the node starts increasing. Now we'll be talking about tree traversal. There are various tree traversal algorithms. We have breadth first search, which scans through the edges, through the levels of the tree. And then we have depth first search, which jumps deep into one particular edge of a tree, and then it carries out searching in other parts of the tree. Then we have our sorting algorithm. We'll be studying bubble sort, insertion sort, selection sort, merge sort, and quick sort. So merge sort and quick sort are sorting algorithms that use the divide and conquer strategy to just keep on dividing the list and then sorting it and then joining all of the elements of the list, find out a sorted list. Now we'll be talking about the different types of algorithms. We have sorting and searching as well as greedy algorithms. So sorting algorithms use nothing but the sorting to arrange the elements in a specific order. As I told before, we'll be studying about these different kinds of sorting algorithms. And it's better, this is a really important concept because it's better to have a sorted list than an unsorted list. If you want to find out the highest value of an element, it's better if you have a sorted list beforehand in your hands. Then comes searching algorithms. There are two different kinds of searching algorithms. The linear search, in which you iterate through the list one by one until you find out the element, and the binary search, where you keep on dividing the list into half until you find the element. And the binary search is nothing but a divide and conquer algorithm, which divides the list into halves and then finds out the solution. Then we have our greedy algorithms, which find out the optimal solution using different kinds of algorithms. We have Huffman coding algorithm, Kruskal algorithm, Digital algorithm. So greedy algorithms are used in AI to find out the most optimum solution in a very short span of time. Now let us talk about the importance of DSA. And DSA is a very important concept because it's used everywhere in software companies, and even big software companies use this concept. And this is the reason why DSA is an important concept in coding interviews and technical interviews. So we live in an ever-changing and highly demanding world where we want high-quality content in a short span of time. And organizing information has become easier because of DSA. DSA provides us with the tools to manipulate and access data from a wide information store in an easy and efficient manner. So using the concept of time and space complexity, we are able to find out the best algorithm suited for our data structure. And DSA is used by companies for building widely scalable applications and making profits. And DSA, I will give you some real life examples of DSA so that you will understand more about the importance of this concept. For example, our social media sites such as LinkedIn and Instagram use graph searching algorithms to recommend different accounts to you based on the network that we follow. And so graph searching algorithms are used in social media networks. And as I said before, hash functions are a concept used in cybersecurity. These are the different applications of data structure and algorithms. And choosing the right data structure and algorithm is also an important consideration when we are practicing DSA. We have to take various parameters into consideration, such as the time and space complexity of our data, and the requirements of our code as well should be considered before we choose the data structure. Now, in today's class, we shall be studying about big O, classes, and pointers. So time complexity has its different notations. We have omega notation, which is the best case scenario, the theta notation, which is the average case scenario, and big O notation, which is the worst case scenario. We shall be studying about big O, which is because big O is the notation that we use in real life scenarios because we take the worst case scenario into consideration all the time. So let's get started to it. So, for example, if you have two different codes, how do you compare which is the better code for your application? If you want to compare two different codes, we can use the concept of big O. For example, you can take your code and run it through a stopwatch. For example, you take your code 1 and run it through the stopwatch, and you find out that it takes 15 seconds to run. And then you can do the same with code 2, and you find out that it runs for a longer period of time. It runs for 1 full minute. So code 1 was faster in terms of time complexity than code 2. And we might say that code 1 is better than code 2, but not so soon, because we can also consider the space complexity of our codes. So maybe code 1 is better in terms of time complexity, but maybe it takes up more memory in our computer than code 2. So this is the reason why we have to find out which data structure is relevant to us based on our needs, whether we care more about the time or the space statement. So this was our introduction to Big O and time complexity. So Big O has various time complexities. We will be going through four of these, which is O of 1, O of n, O of log n, and O of n square. O of 1 and O of log n are the best types of time complexities. O of 1 and O of n square aren't that great. And there is also a few worst scenarios such as the O of n factorial time complexity. And for our coding interview relevant information, we'll be studying about these four big O time complexity notations. So O of 1, which is constant time complexity, is the kind which will take different inputs, different amount of inputs, but it will run in the same amount of time every single time, no matter what the input of your code is. We'll study more about this. And then there is O of n, linear time complexity, which increases linearly based on the amount of input that you have given it. For example, if your time complexity is O of n, and you have made your custom input is O of 5, so it will run 5 times. If it is O of n square time complexity, it will run 25 times. And these are not very efficient. O of n square is not a very efficient time complexity. O of log n, which is the logarithmic time, is the kind which is the kind of time complexity that you will get whenever you use binary search, which I talked about earlier. So as I said, in a binary search, you divide the list in half and half until you find the element. So as a result, you end up having a time complexity of log n, and of log n is very efficient when it comes to a large input data size. And space complexity is a concept that we won't be digging into much deeper. Our course will be mostly revolving around time complexity. So space complexity also has its various parameters such as constant space, linear space, and exponential space. Now let us get started with O of n first. So we'll be talking about O of n time complexity first of all. So we'll be using a code for this. Let's define a function called print items, and it takes in a parameter that is the input size. So in our case, the input size will be n. So this would be our code for I in range of n, print I. This is a very simple code. And if we start running this code, for example, we'll have our own custom input that is 10. And after we run this code, we'll find out that it runs 10 times. 0 to 9, it runs 10 times. So this is simply of n time complexity. We could look at it as in a real life example as well. For example, if you're making sandwiches for people, if you make one sandwich at a time, where n is the number of people, the time it takes to make sandwiches scales linearly with the number of people. So if you need to make sandwiches for 10 people, it might take you 10 times longer than making sandwiches for just one person. Am I clear? Are there any doubts as of now? Does anybody have any doubts? They can raise their hands
We
and tell
can't
me.
see the code.
Yeah, we're not able to see the
Code,
code actually.
which can we see it now?
No, it's actually stuck on the PPT actually.
Okay, so what can you see right now?
The fourth page of the PPT.
Oh wait, so all this time you couldn't see the video, just the types of data structure?
Yeah, just the types of data structure. We thought you're just discussing the pointers, not anything else.
Oh, oh, okay. Can you see
Nah,
it
like
now?
some people, yeah, some people can see the code. Like I can see the code, and also some of my friends can
You
see the
can
code.
see.
Yeah.
Oh,
Again, I
So
okay.
can see
maybe
that
some
4 IN
network
range of
issue.
an.
Okay,
But
so you couldn't see the
no, actually, just a sec.
yeah.
I'll just leave and rejoin
Is it
once.
net issues from your side? Okay.
Just check once.
Is anybody else facing the same issues? I can repeat everything.
No, ma'am.
Okay. Okay, so all these people who have raised their hands, they can't see the codes. Is it like that?
Or like, can we access this PowerPoint presentation?
Oh, you can't see that I'm changing the PPT, the slides right now?
Yeah, I can see it.
No, ma'am, it's visible.
Okay. Okay, okay. Is anybody facing issues with seeing these slides? Is it stuck on the same page for anyone?
Yeah, it's
If
Guys,
still
it's like that,
stuck
then
on.
just
Yeah.
yeah, guys, if you
try
like
to
are facing
rejoin.
this issue, just sync to the presenter. There will be a button down there, sync to the presenter. If you press that, you can just view what she's seeing. Yeah, Kushi, you can continue.
Should I take it again from the fifth page or the fourth page? Or no need?
Give them a brief review. That'll be better, I guess. Instead of just saying it again, again, again.
Yeah, okay. So we studied about the types of data structures that we're going to go through and just the kinds of algorithms that are used by these data structures to find the optimal solution. And we discussed about the relevance of DSA in real life applications. They are used by major companies, like almost all software engineering companies, to organize their codes and run um, and carry out manipulation on large amounts of data efficiently and in a very short span of time. And we also discussed about the various parameters to take into consideration while choosing the data structure and algorithm, such as the time complexity, space complexity, and the specific need of your application as well. Then we had an introduction to Big O, and we spoke about what Big O exactly is. Big O, time complexity is nothing but the amount of time that is taken by a code to run. And there are various kinds of time complexity, which is O of 1, that is constant type, O of n, that is linear time, O of log n, which is logarithmic, and O of n square, that is quadratic. So, like these are the four that we'll be studying about. There are many other different kinds of time complexities as well. But for coding interview relevant purposes, we'll be studying about these four algorithms, these four time complexity types. And out of these, O of 1 and O of log n are the most efficient types. And O of n is the kind that increases in terms of time complexity, time taken linearly, and O of n square increases quadratically. Then we just had a brief overview of space complexity. We won't be digging deeper into space complexity. We'll be mostly focusing on time complexity. And then we were going to start studying about O of n. Are there any issues until now? Just raise your hand and tell.
No, no, no issues.
Okay, done. Let's start again. So we were studying about O of n time complexity. So for that, we'll be defining a new function. Let's call it print items, and it takes in n as the input size parameter. So this is our code. We'll just make a for loop where we just print out the items which are given as the input size. So after we run our code,
Are you
we have
displaying the
given our
code,
custom. Yes,
but it's
are
not
you not
visible?
able
It's
to see
showing,
it?
yeah, I'm seeing only defined print items of n and one play button. That's it.
The video is not going on. Can you see it?
No, the video is not going
Oh,
on.
wait. Okay,
No,
okay, the
no,
video
ma'am,
is not
it's
working.
running properly for me.
For
No,
some people, it's not. Try to rejoin.
We are only
And they might be
showing
facing too much
def
issues.
print items. That
Rajesh,
Yeah.
so they're facing issues with seeing this. What should we do?
No, I believe that once you play the video, we have to click it from our system as well, so that the video plays actually.
Is it like
The
that?
play.
Have you tried to play it?
Yeah, because that's what I'm doing right now. Right now, we pause the video, so I'm not
Okay.
getting the pause icon. But when you play it, I'm getting the pause icon, and then I
what
can
you
review
are
the
doing in the
video.
video.
So you can go through the video yourself. Is it like that?
Yeah, there is a small
Yes.
play option in the
Yes.
video. If you can click that, then it will be synced.
Okay. I will run the video myself, and if you want to forward or rewind or forward it, you can do it from your side as well. But are you able to understand this? Like, are you able to see it properly? Are there any issues with seeing the recording?
No, no, it is coming.
Okay. So as we just saw right now, our code ran n times, which was the input that we gave it to it. We know that the range is starting from 0 to n minus 1. So we could see number sprint from 0 to n 10 minus 1, that is from 0 to 9. So this is basically O of n time complexity, and it increases linearly according to the input size given. Now let's talk about one more consideration to take into account whenever we are finding out time complexity or writing out these big O notations. So we'll come back to the same code, and we'll be adding another code block to it, which is this J for nest for loop, and it will be doing essentially the same thing that our I for loop does. And once we run it, I think anyone can predict that it will run for 10 plus 10 times. As you can see here, our custom input is 10, and our I for loop will be running 10 times, and our J for loop will be running 10 times. So which is 10 plus 10, 20. So after looking at this, you might start to think that, okay, so this time complexity can be called as O of 2n. But we don't do that whenever we are writing out this big O notation. We can't say O of 2n, we'll be calling it as O of n instead. In big O notation, you drop the constant term. If you added another 5, 6 code blocks, you will still be calling it as O of n instead of O of 5n or 6n. Is everybody clear with this? Any doubts until now? I'll take that as a no. Now moving on to our next time complexity, which is O of n square. So we'll take the same code blocks and we'll just nest our J for loop into the I for loop. And now our code will be having a time complexity of n square. We'll see it right now. After we run our code, you'll see that our code has run 100 times. This is our custom input. The input is 10. And as you can see here, it ran 100 times. For For every value of I, you saw J run 10 times as well. So we had I run 10 times, and along with that, we had J run 10 times. Just take a look at it properly, and then you will understand it more. As you can see 0 has printed out 10 times, then 1 has printed out 10 times. And then along with that, our J for loop has run alongside that, as our code says print I and J right beside that. So in total, our code has run O of n square times, that is 10 square, 100 times. If we had our input as 5, it would have run 25 times, and so on and so on. So this is essentially O of n square time complexity. And on the graph, it looks like this. So as you can see, the curve is quite steep, and so we can't really consider this as a very efficient coding time complexity. Any doubts until now? Does anybody have any issues with understanding it?
No.
Okay, let's start. Let's continue. Now, one more consideration when it comes to big O notation is dropping non-dominant terms. Let's see what it exactly is. So we have this O of n square time complexity code block, and then we add another code block to it, which has a O of n time complexity. So let's run this code, and when you run it, you find out that it first ran 100 times and then it ran 10 times. So you can say that the time complexity must be O of n square plus n. But in our scenario, okay, so the input size was just 10. It's a pretty small number. But when it comes to real life applications, you will be having bigger input size. So in those times, this non-dominant term, this O of n, would be very negligible compared to this O of n square. So whenever we're writing this big O notation, we'll be dropping this non-dominant term, and our ultimate time complexity shall be O of n square. So this is essentially what we'll be doing whenever we are writing down our time complexity notations. So first of all, you have to drop the constant terms and you have to drop the non-dominant terms as well. This is also something to take into consideration while writing down your codes and whenever you're showing your time big O notations. If anybody gets any doubts, just raise your hand. Now we'll be talking about O of one time complexity. Let's define a new function which will be called as add items. Again, we'll take an input parameter as n, and we will be returning the value of n plus n. So in this code, you don't have any iterations or any recursion going on. It simply returns a single value. So even if the value of n is 1 million or 100 or 10, it doesn't matter. So this code will run for the same exact amount of time every single time, no matter what is your n parameter given as. So this is what you mean by O of 1. You can't call it as O of 2 or O of 3. It's still noted as O of 1. Now, if we take a look at it on the graph, you can see it's a very, very efficient algorithm. And this is one of the best big O notations, O of 1 and O of log n, which we'll be studying about right now. Now, O of log n is also a very good time complexity to achieve in your code, because if you have a very big number, you will be able to run your code in a very short span of time. Because if you recall the log graph, which we have studied in maths, you'll find out that it as we increase the input, as the value of n increases, the value on the x-axis doesn't increase that much. You'll see it here. So we have a list with 8 different elements in it, and we have to find out one in it. This is a sorted list. So essentially, we use binary search, we divide it, and then we keep on dividing it until we find out the element in it. So we divided it 3 times, as you can see. First, you divided it 1 time, then 2 times, and then 3 times. And coincidentally, you can see that 3 is nothing but log of the size of our input array, which is 8, and which is log of 8 to the base 2, which is 3. The value will be 3, as you can see here. So log of n time complexity is basically log of the input array, size of the input array to the base 2. So in our example, we had an array of length 8, and we did a log operation on it with the base 2. So we found out that our code can be run within 3 steps. So that's a very high efficiency. For example, if you have a very large input size, for example, if it's a number like, if this is your number, if you have a linear search algorithm that continuously iterates through each and every element, then your time complexity would be very high and your code wouldn't be very efficient. So, using the concept of binary search techniques, you can carry out this algorithm within 31 steps. So, which is a very efficient code for us. So, achieving an O of log n or O of one time complexity is very good for your code. As you can see on the graph as well, the time complexity doesn't increase as much with the input size. So O of1 and O of log n are very efficient coding algorithms. Now we'll be talking about one more consideration to take in while writing out our big O notations, which is different input terms. And this is a question that is asked by interviewers to trick you a little. So instead of taking n as the input parameter, you can take in a and b as the input parameter. As we said, the time complexity wouldn't be O of 2n, it would still be O of n. And if you, for example, took a and b as the input parameter, for example, our first code block will be running a times and our second block b times. Would you still consider it as O of n time complexity? I would like to take answers from our people here. Does anybody have an idea of what the exact time complexity would be? Does anybody have any answers to this? Yes. The input parameters are A and B, and one for loop runs A times and another B times. So do you think that the time complexity would be O of n, or would it be something else? Does anybody have any answer to it? They're texting. Okay. Oh wait, is the code still not visible? Is it? Oh wait. Okay, okay. O of n, O of n. Okay, everybody thinks it's O of n. Okay, okay. More answers. Okay, yeah. Somebody gave the correct answer. Rohit, Gana, Veera, Hanikan. Just a second. Just a second. I'm so sorry. Okay, okay. So everybody thinks that the time complexity would be O of n. Just one person gave a different answer. Just everybody thinks that the time complexity would be O of n. Okay. Let's wait for 2 more minutes. Okay, somebody said O of 1 time complexity. Okay, any more answers? I'll give you time to think a little. Just go through the code one more time and see what you think would be the time complexity. Okay, O of n, still everybody's saying O of n. Okay, somebody is saying O of A or O of B, which is higher. Okay. If it depends on the parameters, then it will be O of n into n as number of parameters considered n. This is, we are adding these time complexity. This is not a nested for loop, by the way. If it was a nested for loop, then you would be multiplying the parameters. The answers are still coming in. Okay, yeah, somebody give the right answer. Varsha. Okay, yeah, the time complexity would be O of A plus B. In this case, we wouldn't be calling it as O of n. This is an important thing to take into consideration. If we wouldn't be considering it as O of n, you can't just say that since A can be compared to n, so the time complexity will be O of n total. Now, in our case, the time complexity shall be O of A plus B. And if this was a nested for loop, then the time complexity would have been A of A into B. As you can see here. Yeah, so this was all about big O. So we studied about various time complexities O of n, O of n square, O of 1, O of log n. O of 1 and O of log n are the most efficient time complexity notations. And we have to take various parameters into consideration. That is dropping constant terms. We can't write time complexity as O of 2 and O of 3 n. Then we also drop non-dominants. We can't call time complexity of as O of n square plus n. Even if you have like a time complexity that is a huge quadratic equation, you could have it as n square plus 5n plus 6. No, you'll still at the end call it as O of n square time complexity. And then we took a look at different input terms. So this is also one major thing to keep in mind. Now we are done with studying about Big O. Does anybody have any doubts until now? Why do we drop constants? So this is for the ease of notation. We do this for the ease of notation. We don't want to. We need to give a more generalized notation. You can't write a specific notation for your code. Was that an understandable explanation? Did you understand that? Research and show Rajesh. Any more doubts? After this, we shall start studying about classes and pointers. And all of our data structures will be made from various classes. And we won't be importing any modules in it. Even though Python has built-in modules, we won't be using any of those. We'll be building our own classes to implement our data structures and algorithms. So let's continue. So we have already studied about classes in our college. Let's recap the concept. A class is nothing but a blueprint or a framework that is used for by us to make our own different objects from it. For example, if we can consider a class called as car, a car class. So essentially, our car class will be providing us with a blueprint for our different cars. For example, um, if our car class will be having various parameters, such as the fact that it would be having four wheels and it would be having an engine and all this efficiency and everything. So this is a blueprint that is used by every different kinds of cars. So we can use this blueprint to make our own custom cars. We can have our own different models. We can have a Ford, we can have a Volkswagen, a Skoda, a Ferrari, a Lamborghini, a Mahindra, a Tata. All of these cars have their own different custom functions, but at the end, they use the same blueprint. So in this way, you could look at the concept of classes. Classes are nothing but blueprints that provide us with a framework to build our own custom objects or instances, as we have learned in object-oriented programming. I'll give an example of the car class as well. But for now, we'll be using the cookie cutter analogy. So we'll be defining a cookie class for this. Can everybody see the screen, by the way? Any issues with this? No, right? I'll take that as a no. So in our
No
class,
issues.
whenever we okay, so whenever we are defining our class, you will first have an initialization function, which is called the init function. And in every class, whenever we are writing out our methods, we'll be having a self parameter. You can call it as any parameter, but the self parameter is used for referencing to the specific parameters of and attributes of our class. We'll study about it more. So first we'll initialize our class. So the parameter that is taken in this init function is the parameter that is taken by our class. So whenever we're writing out our own object of this class, we'll be passing the parameter that is given here. I'll show you that. So this is our init function. As you can see, in our case, we'll be having self and color as two of our inputs, and we'll be defining this self dot color as color. And then we'll have our own object of it. As you can see here, cookie1 is equal to this cookie class uh, object, and it takes in this color as its parameter, which is the same parameter taken by our init function. As you can see here, we have one cookie which will be having color as green. We can have another cookie instance which will be having color blue. We can define more functions, which will be the get color, which will return the color of our cookie. This won't be taking in any other parameters because there's no need. And then we have our set color method, which will be taking in color as the input parameter, and we'll simply return the self dot color, the color of our cookie. Now let's take a look at this code. When we run it, you'll get the color of your cookie. So essentially what we have done is we have taken a class and we've customized it for our particular needs. So we got a green color cookie, we got a blue color cookie, and you can also change the color of the cookie with this set color function. So we took our cookie1 object and we set color to yellow, as you can see here. And after we run this code again, you'll see that the color of cookie1 has changed. Let's see here. Yeah. So as everybody can see here, first our cookie1 was green and now it's yellow. This is how we can use our set color function. Now let's take example of the car class. I will have to stop sharing the PPT for that. Just a minute. Now I'll be sharing my PyCharm console with you. Just wait a minute. So can you see this PyCharm console right now? Is it visible? Rajesh?
It is visible, Kushi.
Okay, so we have defined our car class here. As you can see, we have our init function, which takes in parameters of self, speed, and color. And every single time we define a class, you have to take in the self parameter as well. It's done in every single time whenever you define a class. This is one thing to keep in mind. So we have our speed and color parameters assigned. And then we have another function which will be returning the values of color and speed based on the kind of object that we have created. So here we can see we have created two different car objects, and one car has speed as 70 and the color as red, and another car has speed 60 and the color as white. So after we run it, you can see as our drive function here has said that it will be printing out the color and it will be printing out the speed of our car. And so in the output, you can see that the red car is driving at 70 kilometer per hour and the white car is driving at 60 kilometer per hour. And now I would like to talk about the importance of the self parameter. Just a minute, let me comment out all of this code. So for this, we'll be using another example, which is the robot class. So how would our function know which instance of the class should I call? So this is the reason why the self parameter is so important. If you didn't have this self parameter, the code wouldn't know which instance is supposed to be called. So as you can see in our class, you have input parameter as name, and it will then we have a greet function which will be returning the name of your robot. Then we have made our instances of robot class. One is a robot named as R2D2 and another is RC3PO. Now let us run this code. So as you can see, our code was able to refer to the input parameter that was that was assigned from us in our code. Um, I will tell you what exactly Python does. It basically refers to the first input parameter given here. For example, if I change the name of self to me, that is also fine. By convention, we use self as the input parameter, but you can use anything. It won't change anything. Everything else is the same. So self parameter is important for referencing the specific attribute that is used. Is this clear? So in programming, a pointer is a variable that stores the memory address of another variable. And the concept of pointers is mostly used when it comes to the concept of linked lists. And pointers is mostly used in C and C++. These are lower level programming languages. Python, instead of using pointers, it uses references, but we can also define our own pointers in Python as well. So pointers are used because the different types of data are either mutable or immutable. I would like to ask people to tell me, do you know which are examples of mutable and immutable characters? Can you tell me if int, character, and string are examples of mutable data type or immutable data type? First of all, can somebody tell me what is a mutable and immutable data type? Any
Mutable
answers?
means we can change them, but immutable
Okay.
we can't change.
Yeah, correct. Okay, correct. Integers are immutable, correct. And lists and dictionaries, are these immutable or mutable?
Mutable.
The list or dictionary immutable data type or immutable data type? Mutable, correct. Everyone knows it. So, whatever data type we are going to declare into our variables whenever we are writing down our Python codes, they will be assigned into various memory addresses in our computers. And these memory addresses are recorded are referred to by our pointers. So essentially, whenever we're calling a pointer, it will be pointing to the memory address of our variable. Now we'll be talking about integers and dictionary. We'll be taking their examples into consideration whenever we're talking about Python pointers for our example. So let us take a variable called as num1 and we'll be assigning it the value of integer 11, and then we'll take another variable which will be equal to num1. Num2 is equal to num1. And if we so what we're essentially doing is pointing num2 to be equal to num1. And when we run this code, we will be finding out the memory address using this id function. You can write down this code if you want to. So we find out this is the memory address that num1 and num2 are pointing to. So they're both pointing to the same memory address. Now we'll be changing the value of num2 to be equal to 22 while keeping the value of num1 the same. Let's see what happens now. So after we first had our value of num1 equal to 11, num2 equal to num1, and now we are changing the value of num2 to be equal to 22. Let's see what happens to our code after that. The pointers. So as you can see here, this was our memory address when num1 and num2 both were equal to 11. And after we change the value of num2 to be equal to 22, we can see that num1 is still pointing to the same memory address, that is the memory address of 11, and num2 is now pointing to a different memory address. This is because integers are immutable and you can't change their memory address even after you change the value. But something interesting happens when you do the same for a dictionary. So, for example, you took dict1, which is equal to value 1, value equal to 11, and then you took another dictionary and you equated it to dict1, and it's pointing to the same dictionary. After we run this code, we can see what happens. Just a second. Okay, so we are not going to yet change the value of the second dictionary. So as you can see, the value of our first dictionary is 11, and dict2 is pointing to dict1. And when we print out the memory address of both of our dictionaries, this is what you'll see. Just pay close attention to it. And after we change the value of this key for second dictionary to 22, you'll see what happens. After running this code, you'll find out that dict1's value has also changed to the same value as dict2. And the memory address has been changed, but it shouldn't actually change. It's probably because of the environment or runtime, whatever console we're using. But usually the memory address doesn't change, but in this case, it has. So as you can see, since dictionary is a mutable data type, you saw that the value of the first dictionary also changed along with the value of second dictionary. So this is where the concept of pointers can be clarified. Yeah, you can see that the memory address is also the same for all of them. And there is one more concept that I would like to explain. If you have both of your dictionaries, first of all, they're pointing to value 22. And yeah, first I would like to explain how this concept of pointers can be used. So whenever you're defining your linked list, all the elements would be nodes, and nodes are actually essentially dictionaries. And one key would be value, which will be storing the value of our element, the node, and one would be the pointer, the next pointer, which will be pointing to the next element of the linked list. And in a linked list, since we'll be defining them as dictionaries, if you'll find out that even if you change the value of the element, it will be still pointing to the same memory address. When you study the concept of linked list, you will understand what I'm exactly trying to say from this. So we had dict1 and dict2 point to a certain dictionary value, and if we take another dictionary, 3, which is pointing to another value, and we assign dict2 to be equal to dict3. So since dict2 is already equal to dict1, dict1 will also start getting pointed to this third dictionary. So at the end, what will be happening is all three of your dictionaries will be pointing to value 33. So what will happen of this dictionary which was containing value 22? So since there is no way to access it, Python will be using the concept of garbage collection to get rid of this value. So this was all for today. This was the concept of pointers.